Okay, everybody, today we are going to be talking about quadratic word problems, and this is something that is going to be coming up again this year as well as next year. A few tips when dealing with word problems. First and foremost, draw a sketch if you think that you need to find the shape of the graph, okay? We're going to do an example that does need the shape, another example that doesn't. And it's always a good idea when you can to double check that you have drawn your graph correctly using graphing software such as Desmos. I'm asking you to really read the question, understand what the question is asking, and what information do you need in order to succeed. Let's look at our first example here. On planet X, the height of an object fired upwards from the ground follows the parabola h equals 48t minus 16t squared, where h is the height above the ground in meters, and t is the time in seconds. Let's start by drawing a sketch. Well, in order to draw a sketch, we are asked to, we need to find our x-intercepts, our y-intercept, and our vertex. So let's find those pieces of information. I'm going to start with my x-intercepts. Okay, and those are found by setting my equation equal to 0. Okay, setting it equal to 0 is mandatory and absolutely needed. I can then factor, I can pull out a 16 from both of these terms as well as a t, leaving me with 3 minus t. So then option number 1 is that 0 is equal to 16t, or 0 equals t. My second option is that 0 equals 3 minus t, and therefore 3 is equal to t. So those are my two x-intercepts that I'm going to be working with. Okay. I can then find my vertex. My vertex, the x-coordinate, is located halfway between my two x-intercepts. So I'm going to say, okay, let's do 3 plus 0 divided by 2. 3 plus 0 is 3 divided by 2. I'm going to put that as a decimal as 1.5. I can then find my h at that point in time by substituting 1.5 into my equation. So that's 48 times 1.5 minus 16 times 1.5 squared. 48 times 1.5 is 72. Minus 16 times, then 1.5 squared is 2.25. 16 times 2.25 is equal to 36. So my height is actually 36, and I can determine that my vertex is located at the point 1.5, comma 36. Last but not least, I need to find my y-intercept. It's pretty obvious that it's going to be at 0 because my x-intercept, my first x-intercept, is also at 0. But let's just do it just for good measure. Okay, so my y-intercept is, we are going to set t equal to 0, so that'll be 48. Let's just do this again. H is going to be equal to 48 times 0 minus 16 times 0 squared, so h is equal to 0. And now that we have those pieces of information, so our two x-intercepts, our vertex, and our y-intercept, we can go ahead and graph. Okay, I've already sketched out an axis for you here, so I have my time on my x-axis, my height across my y-axis there. Let me just zoom out a little bit. Okay, when you're graphing, you always want to make sure that you are adding those axis labels and that you are indicating what your scale is on your axes. Okay, so here, every square box is going up by 2 versus it takes me 4 square boxes to go 1 across my x-axis. Let's start by plotting our two x-intercepts. Okay, so we have an x-intercept at 0, and we have an x-intercept at 3. My y-intercept is overlapping with my x-intercept here, so it's also at 0. And my maximum, or my vertex, is located at 1.5, comma 36, 32, 34, 36. So it's located right there. We can now draw our parabola. It's okay if it's not a perfect shape. You just want it to look like the shape of a parabola. Okay, let's go back to some of our questions here. So, determine the maximum height. Well, we have already found the maximum height. That was our vertex, so we can write that as being our maximum height is the vertex. So I can just answer the max height is 36 meters, and I can specify the vertex. How much time does it take before it hits the ground again? Let's just reconsult with our graph here. So we can imagine that we are starting from 0 and it's going up and back down. So we're starting at the ground. We are asked how much time it takes before it hits the ground again. Okay, we can see that as it's going up, time is elapsing, and it hits the ground back again at 3. So it's our second x-intercept, and so I can just answer that question nice and simply. It takes 3 seconds before it hits the ground again. Awesome. Okay, how long is the object at or above 20 meters? How long is it at or above 20 meters? Maybe this is the height above an object. We don't know. All we need to know is that how long is it above 20 meters? We can consult our graph for this. We can say, well, 20 meters is here. Okay, so I need to find the distance between here and here. You can guess by looking at your graph. You can make a rough estimate. Your rough estimate will be pretty good, but there is an actual way to determine this mathematically. Let's just look at whatever our rough estimate would be. Recall that every 4 squares is equal to 1 second. So I'm going to say, well, there's 1, 2, 3, 4, 5, 6, 7 whole squares, okay? And 2 about half squares, so it's going to come up to 8 squares, which is equal to 2 seconds. So my estimation is that it takes about 2 seconds when it is above 20, at or above 20. So this amount of time is about 2 seconds. Now we can determine this mathematically, okay? We are asked to find how much time is elapsing, okay, at or above 20 meters. And so in my equation, let's just refresh, my equation here was h is equal to 48t minus 16t squared. Well, we are given a height. Our height is 20 meters. So let's try to figure out at a height of 20, what is our time? Okay, in order to solve this, we're asked to solve for t. I'm going to need to rearrange and then factor. So I'm going to start by setting the left-hand side equal to 0. I'm then also going to rearrange to put things in descending order of degree. So I'm going to put my negative 16t squared plus 48t, and then I have a 20, that'll become a negative 20 on the left-hand side. I can go ahead and I can factor, let's common factor first. I'm going to common factor out a negative 4 to give me 4t squared minus 12t plus 5. Okay. In order to factor this here, I need to find 2 numbers that multiply to 20. Okay, if we want to write out our x, I need 2 numbers that multiply to 20 and add to negative 12. That's going to be negative 2 and negative 10. So I'm going to factor this using decomposition, so it'll be 0 is negative 4 times 4t squared minus 2t minus 10t plus 5. Within our first 2 terms here, I can pull out a 2t, leaving me with 2t minus 1. And I can pull out a negative 5 here to give me 2t minus 1 once again. Let's finish off our factoring here, so I can pull out a 2t minus 1, and then we have 2t minus 5. Okay, so all we really done here, just to recap, is I set my height equal to 20, which is what the height minimum that we were looking for was, okay? And that makes sense because if you think about your parabola, whenever you're finding the x-intercepts, all you're doing is setting the height equal to 0. Okay, in this case I say, no, I want the height equal to 20. And that's what we're solving here. Now in order to find t, I need to set both of these brackets equal to 0. So I'm going to say, well, 0 equals 2t minus 1. 0 equals 2t minus 5. And so I'm going to rearrange. I'm going to pull the 1 over here, divide by 2. So either t is equal to a half, or, and again, I'm going to pull the 5 over here, divide by 2. 5 over 2 is equal to t. So those are the two intervals where, if you imagine your parabola, let's go back to our parabola for a second here. Okay, this is why we can't totally trust it, was because that we had said, well, time is equal to a half when I'm at 20. So time being equal to a half, my dot should have actually been right about there. Okay, and same, we were looking at 5 over 2, which is at 2.5. So my dot should have been right about here. And this is why you can't totally trust your graph, because you can see that, we just kind of eyeballed it, we looked at it by hand. Not so bad, but these were the actual points that we should be going through. So we're not far off on our graph here. But the question was asking, how long does it take in between those two time frames? So I need to subtract them in order to figure out how long the object is above 20 meters. I need to find the difference between these two times, okay, in order to be able to find that gap in between the two. So I'm going to say just over here, I'm going to do 5 over 2 minus 1 over 2, which is equal to 4 over 2, or just 2. So I can say, therefore, it is at or above 20 meters for 2 seconds. Okay, not so bad. Let's look at another example here of a quadratic word problem, but that doesn't require the use of a graph. The sum of the squares of 3 consecutive integers is 149. Find the integers. In the previous example, it was very useful to us to use a graph because we were talking about the line that was being followed by an object as it was flying through the air. It's very easy to visualize that it could go up and then it's going to hit a peak and then it's going to come right back down. Here we're not talking about the path of anything. We're just talking about numbers. Okay, very similar to some of the word problems perhaps you saw in previous years or in previous lessons. So we're going to tackle this using our regular word problem skills. I'm going to start by identifying my 3 numbers. So I'm going to say let x that means that x plus 1, because they are consecutive, is the second number. And finally, x plus 2 is going to be the third number. And I'm going to let s represent their sum. Now let's find the 3 integers based on the information that we have. So the sum of the squares of 3 consecutive integers. So I need to square my 3 integers here. So the first one is going to be x squared. The second one is going to be x plus 1 squared. And the last one is going to be x plus 2 squared. We know that the sum is 149. And now all we have to do is simplify the right side of our equation here. So x squared is just x squared. This is going to be x squared plus 2x plus 1, and then x squared plus 4x plus 4. Let's simplify this. I'm going to combine some like terms. 149. I have 3x squareds. I have 6x. And I have 5. Now recall, in order to determine in order to solve for x in this case, one of our sides of our equation needs to be equal to 0. So I'm going to go ahead and move 149 over. Don't try to start factoring right away. I mean, immediately you'll probably recognize you can't, but we have to have one side equal to 0. So I'm going to go 0 is 3x squared plus 6x, positive 5, and then this is going to be a negative 149 is going to give me negative 144. Okay, I can common factor first. Always common factor first if you can. I'm going to common factor out of 3, leaving me with x squared plus 2x minus 48. I'm looking for two numbers that add to 2 and multiply to negative 48. Those two numbers are going to be, actually let's write them out over here. Two numbers that multiply to negative 48 and add to 2. Those two numbers are negative 6 and positive 8. So I can go ahead and factor this to be x minus 6, x plus 8. Okay, okay, so I need to find x by setting these two brackets equal to 0. So option number 1 is that x minus 6 is 0, which is just x is equal to 6. And option number 2 is that x plus 8 is equal to 0, or that x is equal to negative 8. Both of these are integers, so both of these answers are going to be correct. Let's just double check here. So if I start at 6, remember that x was my first number. Okay, I'm going to go 6 squared plus 7 squared plus 8 squared gets me 149. Okay, as well if I have negative 8 squared plus, and then if you want to go up, it's going to be negative 7 squared, so negative 7 squared plus, and then I go up again, negative 6 squared also is 149. And notice, because when you're squaring a negative number, okay, it becomes a positive, and that's why it makes sense. So it's either going to be 6, 7, 8, or it's going to be negative 6, negative 7, negative 8. And if you think about it in terms of consecutive terms, it has to be negative 8, negative 7, negative 6, because that's what they're getting bigger. Okay, so we have two options here. I'm going to finish off with a therefore statement. Therefore, the integers are either plus minus 6, plus minus 7, or plus minus 8, okay, as we just demonstrated. That concludes that word problem. Let's do one more example here. A rectangular field is to be enclosed with 200 meters of fencing. It has an area of 1,600 meters squared. Find the dimensions. Okay. Well, we know we have a rectangular field. I'm just going to start by drawing a diagram. We know that the total area is 600 meters squared. It's not very rectangular, but you get the idea. This is 1,600 meters squared. And we know that this side plus this side plus this side plus this side has to be equal to 200 meters of fencing. Okay. Now, in order to find the area of a rectangle, our formula is length times width. So let's go ahead and let's use those variables again, length and width. Okay, I'm going to set up some let statements. I'm going to say let L represent the length of the field, and I'm going to let W represent the width of the field. Okay, two pieces of information. We know, first and foremost, we know that L times W has to equal 1,600 because that's our total area. What we need to find out, we have our perimeter as well, so our perimeter is 200 meters. And so I'm going to use the perimeter formula here. It's 2 times length plus width. We are now dealing with a system of equations that we had seen way back, okay, in one of the earlier units here. two variables, two equations. I need to figure out a way, okay, to rearrange my variables and then solve for one of them, okay? A lot of you were very commonly using solving by elimination, and that works in a very linear sense, but I'm going to suggest that we solve by substitution here. I'm going to go ahead and I'm going to try to isolate one of my two, either length or width here. I'm going to divide both sides by 2, giving me 100 is equal to L plus W. And let's isolate for L. So I'm going to say that then L is equal to 100 minus W. Knowing this information, I can substitute this into my area equation. Okay, so I'm just going to go ahead, substitute 100 minus W in for L. That's going to give me 100 minus W times W is equal to 1600. If we want to go ahead and expand this, okay, that's going to be 100W minus W squared is 1600. And now this is starting to look like a quadratic problem. We officially have a squared, and in order to solve for W, solve always means one side of the equation has to be equal to 0. So let's make that happen. Let's move our 1600 over, and let's do some rearranging here. So I'm going to have negative W squared plus 100W minus 1600 is equal to 0. I'm going to factor out a -1 just so that my A is a positive value. It's a little bit easier to work with. Okay, and now the question is, well, I have to factor W squared minus 100W plus 1600. Okay, which means, and if I draw my little X over here, I need two numbers that multiply to 1600 and that add to -100. Those two numbers are going to be -20 and -80. Okay, so I can go ahead and I can factor this right away. I'm going to say negative. It's going to be W minus 20, W minus 80 is equal to 0. Okay, now in order to find W, I have to set up both of these as equal to 0. So option number 1 is that W minus 20 is equal to 0, which is just W is equal to 20. Option number 2 is that W minus 80 equals 0, or W is equal to 80. These are two options for our widths. So let's find the corresponding lengths, okay? We had said that the length is 100 minus W. So if W is 20, 100 minus 20 is going to give me the length, which is 80. Likewise, if length is 100 minus 80, length is 20. So we can see pretty clearly here, we have the same dimensions, just vice versa, and it's, it doesn't really matter what's width and what's length. 2080, 2080. So our dimensions of our rectangular field are going to be 80 by 20, and we're not going to argue if that's going to be width or it's going to be length. It's just going to be 80 by 20. So I can set a conclusion statement here. Therefore, the dimensions of the field are 20 meters by 80 meters. Okay, this type of a problem where you have a certain amount of fencing in an area to cover is a very common problem, so make sure you fully understand this before trying some on your own. Great work, everyone.